So in 2.3.3, we're referred back to problem 2.1.4. It's a problem we did previously. We have two cards are drawn from a pack of cards, and we want to look at the number of hearts we would get. So two cards, how many hearts? And it wants to know, is the expected number of hearts bigger if you draw with replacement or without replacement? So now we're not going to redo it here, but you can go and look at the previous video for problem 2.1.4. In the previous video, we found our possible x values, so 0 hearts, 1 heart, 2 hearts, with each of the probabilities. So let's focus on with replacement first. So again, previously we had to figure out how many hearts we could get and the probability for each in the previous problem. Now we just have to find the expected value. So the expected value for, I'm just going to put x there, I guess. The expected value is just going to be 0 times 0.5625 plus 1 times 0.3750 plus 2 times 0.0625. So if you don't remember, the expected value of x is just equal to the sum of each x value times its probability. So each x value times its probability, and we'll just sum them all up. Okay, so I put this into my calculator and I get 0.5. So on average, if I draw 2 cards, I should get about half a heart per 2-card draw on average. So if I do it many times, then on average, if I draw 2 cards with replacement, I'll get 1/2 heart. Again, on average, which is why we get a fraction, which actually makes a lot of sense because there are 4 different suits. If you're drawing 2 cars, 4 suits, you probably have about like half. It's kind of what I expect to get for hearts, and I probably expect to get half a card from diamonds, half a card from clubs, half a card from spades, because everything is equally likely. So now let's try again without replacement. So here it was with replacement. So again, we do the exact same thing. So the expected value without replacement, I'll just call it a y instead, is going to be, we'll use these values here. So I do 0 times its probability, 0.5588, plus 1 times 0.3824, plus 2 times 0.0588. Okay. I put all this into my calculator, and I get 0.5 again. Now this is very interesting. I would have expected the expected value to change if I hadn't thought about it. I would have said, these numbers are slightly different, and these numbers are slightly different, and I would have expected my final answer to be slightly different. But it turns out that these probabilities are balanced in just such a way that when you put it all together, you get the same answer. Now, if you think about it, this again does make sense to me because I would say I have, again, 4 suits. I have hearts, diamonds, spades, and clubs. Every one of those should be equally likely. So whether I'm drawing with replacement or without replacement, I'd still be equally likely to end up with 2 hearts as I would 2 spades or 2 diamonds or 2 clubs, whether I do it with replacement or without, because my 4 choices are all equally likely, and that's what ends you up in this kind of interesting predicament where your expected value is the same with replacement, without replacement. So for me, the reason it makes sense in my mind is because my other choices are all equally likely. So I'm equally likely to get hearts as diamonds, whether I do it with replacement or without. And so that's why it's still the 0.5. But just kind of an interesting little time where you do 2 different things and the expected value with different values ends up being the same.